सार ज्ञान मंत्र में आपका स्वागत है। आज मैं आपको क्लास 11th का फिजिक्स वेक्टर के बारे में कुछ इम्पोर्टेंट कंसेप्ट शेयर करूंगा। तो सबसे पहले शुरू करते हैं वेक्टर क्वांटिटी। वेक्टर क्वांटिटी क्या है? वेक्टर क्वांटिटी इज द फिजिकल क्वांटिटी having magnitude as well as direction and combined according to the certain rules of addition. Now, how we can represent vector? The vector can be represented by three ways. First, putting arrow over symbol representing vector. This is showing as a AB vector and BC vector. Next, single letter with arrow. If we write V and arrow is above the V, that is the vector. F vector. And bold face letter as shown in this AB, BC, small v and f. This is the way of representation of vectors. Now we see the magnitude of the vector. The magnitude of a vector, suppose vector v or vector f, may be written as mod vector v or mod vector f. This is also called the absolute value of vector v or vector f. Now we will see the component resolution of a vector. Component resolution, the component that vector can be vector have the components. Components, if there is a vector in a x and y plane as shown in the screen, we take a vector A and is represented by OA and make an angle theta with the x-axis, and now the projection of vector A along the x-axis and the y-axis as indicated by AP and AQ, and OP then we consider as AX, that is the x component of vector A, and AY is the y component of vector A. Now here clearly already discussed, OP is equal to projection of vector A on x axis is equal to AX, that is also called x component of A vector, and OQ the projection of vector A on y axis as indicated by AY and also called y component of vector A. Now how we will calculate x? The x in triangle OAP, if this is right triangle and theta is the angle AOP, then cos theta is equal to base by hypotenuse. Here base is AX and hypotenuse is OA, that is A, then cos theta is equal to AX by A. Now after simplifying we get AX is equal to A cos theta. This can be considered as equation 1. Now similarly we can calculate AY, y component of vector A, that is AY is equal to A sin theta. So now we have already calculated x component value. X is equal to A cos theta and AY is equal to A sin theta. Now squaring and adding equation first and second, we get AX square plus AY square is equal to A square cos theta square plus A square sin square theta. After rearranging, A square in bracket cos square theta plus sin square theta. As we know that cos square theta plus sin square theta is equal to 1, then we get A square into 1, and that is equal to x square plus AY square is equal to A square, and then A is equal to square root A square x plus ay square, and this is called the magnitude of vector A. Similarly, if we divide equation 2 by 1, we get tan theta is equal to ay by ax, and theta is equal to tan inverse ay by ax, and this theta is the direction of vector A with respect to the x-axis. Now we will see unit vector. The vector whose magnitude is 1. I, j, k are unit vector along x-axis, y-axis and z-axis respectively. Here as in shown in the figure. Now if we take a vector A in xy plane, we can write vector A equal to xi plus ayj, and here is the conclusion. If a vector is resolved in two vectors which combined effect is same that of the given vector, then the resolved vectors are called as the component of that given vector. Here vector A has two components x and ay, and this A vector can be resolved in their component using the unit vector I and j. Let us see a vector r is equal to vector A plus vector B. Here it can be considered as equation 1. Now these two vectors are vector r and vector A plus vector B are equal if and only if their corresponding components are equal. Corresponding component, the component of vector r are rx and ry. Similarly, components of vector A and vector B will be ax and ay and bx and by. Then we see that rx is equal to ax plus bx and ry is equal to ay plus by, and now this equation can be considered as equation 2. Now vector A, we have already discussed that vector A is equal to xi plus ayj, and similarly vector B is equal to bxi plus byj. This can be considered as equation number 3. Now from first and third equation, r is equal to axi plus ayj plus bxi plus byj. Rearranging this, we get ax plus bx in bracket and I plus ay plus by in bracket and vector j, and therefore vector r can be written as rxi plus ryj, as the value of x plus bx is rx and value of ay plus by is equal to ry as indicated in equation 2. So then this we can calculate the magnitude of vector r as the r is equal to square root rx square plus ry square. This is the magnitude of the vector r, which is the sum of two vectors, vector A and vector B. And similarly, the direction can be indicated by theta. Theta is equal to tan inverse ry by rx. This is the direction of vector r with respect to the x-axis. Now here one thing is more that the R is the resultant of two vectors, vector A and vector B, and similarly we can get the resultant of many more vector A, B, C, D, or vector A1, vector A2, vector A3 up to vector AN, and similarly we can get the magnitude as square root of Rx square plus Ry square, and direction similar theta is equal to tan inverse Ry by Rx, and we get Rx is equal to as in the discuss. So here is the end of this vector, and now in the next video we will see the product of the vectors, dot product and the cross product, and after this we will solve some simple problem to clear your concept. धन्यवाद। अगर वीडियो अच्छा लगा हो तो लाइक एंड सब्सक्राइब जरूर करें ताकि मैं आगे आपके लिए और वीडियो बना सकूं। धन्यवाद।